you know when it's time to upgrade your line and how to do it successfully, presented to you by the Motion Control Association. This webinar will be recorded, and an email with a link to the recording will be sent to you within the next 24 hours. The recording will be available for 12 months. However, we do not provide copies of the slides. If you have any questions on the material, please feel free to submit your questions via the panel on your right, and they will be answered if time permits. However, if there's not time, you may also contact the speaker directly after the webinar. My name is Kathleen Straight with the Motion Control Association, and our presenter today is Kristen Lewatsky. Kristen has written about motion control and automation for more than 7 years. As a technology writer, she covers a variety of other subjects, ranging from memory and microelectronics to nanotechnology to lasers and photonics. She worked as an engineer on NASA's Chandra X-ray telescope before switching to writing about technology. Her background is in physics and engineering. Kristen, I'm handing it over to you now. Thank you.
Thank you, Kathleen, and welcome everybody. Thanks for taking the time to sit in. I'm going to talk today about upgrades. A couple of years ago, I was talking with a system integrator, and he made a comment that old machines never die. They just get unpacked and taken to a new factory and put back together again. Which, if you walk through most factories, you're going to see a fair amount of machinery that's 20, 30, 40 years old. I mean, this stuff is built to last. It's got really, really solid housings and all that, but the part that doesn't weather so well is all of your electronics and the action parts of it. And that's where kind of that old mentality that a lot of us grew up with, if it ain't broke, don't fix it. Let's just keep it flowing along. We know how to maintain it. We know how to keep it running. Well, that's very well and good, but that's not necessarily a dynamic that's going to help you in the current market. I mean, we've been in the economic downturn. We've been coming out of it for the last several years. Everybody's trying to run as lean and mean and competitive as they can. Staying in one place and doing the same old thing you've been doing for 20 or 30 years is not going to give you a competitive advantage. It's not going to keep you ahead of the market. So yeah, we say these machines, are built to last and all that, but as I said, they're not necessarily going to be doing the best thing for you. I would guarantee that if you look at the machine that you're running today that's that age, you're going to be paying more in energy bills and power than you would with modern components. Just everything's made more efficient right now. But there are bigger issues beyond just that. That would be if you're looking at a straight one-to-one going from a motion control system with servo motors and drives and all that. If you're looking at upgrading from something that's kind of lower tech, the savings are going to be even bigger. I mean, in the this isn't a machine example, but in the drilling and mining industry, they use mud in order to facilitate the process. And they used to just pump it at a steady rate, and then somebody got the bright idea of, hey, let's put a servo valve in front of it. We'll still run the motor, but the valve can cut on and off, and that'll cut off our mud. And yes, it provided a savings, but it also introduced a couple of other issues. When that servo valve closes, there's a pressure spike because 1 minute the mud's flowing, the next minute, bam, it stopped. Now, if you've got any water contaminant in there, if you remember back to thermodynamics, you increase pressure, you're going to increase heat. And if you've got water in that mud, it's going to vaporize. Suddenly you get a ton more pressure, and things can start failing, they can start cracking, they can even start exploding in the worst case scenario. So one thing that people are starting to look at is using variable speed motors on those guys. So not only are you eliminating possible failure, catastrophic problems, but you're also reducing your energy. You're not going to be running your motor 24/7 anymore, or the entire time the system is running. Now you're going to be able to reap some benefits by keeping it turned off. Same thing with hydraulics. If you're running hydraulics, you've got to keep them charged. You've got to keep those pumps running all the time. If you swap out the hydraulics for servo motors, and there are some really large servo motors out there that are able to run dockside cranes and everything else, that's totally viable as a substitute for hydraulics. So that's one thing right there where you're putting out more money with old equipment. Throughput's another one. I was talking with apps engineer last week who mentioned a converting company he's been dealing with, and they've done, I think it was 3 upgrades over the last 20 years. They started out with a throughput of 80 parts per minute, and they're currently up to 340 parts per minute. The throughput that you can get from modern products is amazing. Another benefit you're going to get out of it is operator time. It depends what you're looking at for swapping out. If you're upgrading from a mechanical system, changing recipes is arduous. You got to take things apart. You got to change out cams. Even if you're doing electronic shafting, older systems don't make it as easy with HMI and the recipes and so on. So you're putting more pressure on the operator. But another thing that the modern technologies can do for you in the motion is machine safety. I mean, if you've got a jam and you've got a manual system, or even kind of a 5 or 10-year-old motion system, you're kind of stuck getting in there and fiddling around with it and shutting things down and getting your hands in and removing the jam. Whereas if you've got a safety PLC on your system that's compatible, now you can jog the machine. You can use safe torque off. You can use a number of different modes that are going to let you use the power of the machine to clear the jam. So you're back up and running faster. Your operator is not having to work so hard. They're not having to endanger themselves. Another area is maintenance. Modern components, you've got a lot more intelligence involved, so it's not something where you're either looking at a calendar to decide when to do maintenance or finding out you need to do maintenance when the line goes down. They can do condition monitoring. They can warn you when the current's running high. They can warn you when there are issues. They can even do shop floor to top floor messaging. So it's a lot easier. You've got components with electronic nameplates that can be plugged in, so you don't have to spend a lot of time entering parameters. It winds up just kind of simplifying the process top to bottom, and the sum total is you're going to get less downtime. So all of those are the good reasons about what upgrading can do for you and why you don't necessarily want to stick with a tried and true, even if it is familiar. Human nature, what we really tend to find is the reason companies do upgrade, there are 3 of them basically. The first one is the one I like to call the kicking and screaming reason, which is your vendor has taken the product end of life. They've sunsetted it, and you don't have a choice in the matter. So no matter how you love it, that's going away. You're going to have to figure out an alternative. And something to keep in mind, by the way, with when products do go obsolete, your cost is going to go up there. They're no longer, that's no longer their marquee product. They may be sunsetting it because some component of it has been discontinued by their manufacturers. So in general, the cost is going to go up. They're going to stop supporting it over time, and eventually you're going to be out there kind of twisting in the wind. So that's one thing that tends to drive users. Another thing is component reliability. I've done a number of case studies over the years when I've been talking to an end user, and they've said, yeah, the components vendor is just fine, but they were failing too much. and we just couldn't afford it, so we had to go to another vendor. So, that's always going to drive you to look for an upgrade. And then the third part is going back to what we discussed on the previous slide. They're not performing at the level that's going to make you competitive. And upgrading, huge, huge, huge bang for your buck. They estimate it's about a 20% increase in performance for upgrading your machine. And if you compare that to buying an entirely new machine outright, that's multi-$100,000. So if you're trying to get some improvements in your manufacturing process and so on, that's a good way to do it. So let's see, one example, printing machine company, they actually upgrade the machines for the binding and book publishing company, and had the same problems. 30-year-old machines, worn out, the electronics are obsolete. They upgraded to smart drives and got a lot of the benefits I was just talking about, but one of the key benefits that they were aiming on was to have on-the-fly phasing between axes, because these machines have dozens and dozens and dozens of axes. So ultimately, they said they got about a 20% increase in throughput. That's pretty compelling. Another example is a bakery company. They wound up doing an upgrade as well. Same thing drove it. The controls were just no longer effective. Benefits that they got were, again, the network components, easier changeover, and that came just from updating the controls. So part of, we're talking about the reasons why to upgrade, but how you upgrade is just as important. You've really got to look beyond what's obvious there. You don't want to just jump along and stick with a new version of the old technology. You need to see where things have gone and see how that's going to benefit you. A picture right here is a magnetic encoder, which, despite the way it looks, is operating just fine. And it's something to keep in mind when you're looking at these components and things. One of the big mistakes that companies in the kicking and screaming category do is they go looking for a one-to-one substitution for the components that have been taken out of their hands, and that leaves out so many economies of scale and so many benefits, because it's kind of one of those things where you don't even know the questions to ask if you're just operating on the old technology. Let me give you an example. If you were in some sort of mill-type application, then 30 years ago, to get the resolution you wanted, you probably needed to go with an optical encoder, because magnetic encoders just couldn't do it. And downside, as we all know, optical encoders, they don't like dirt, they don't like contamination, they don't like heat, and probably had to deal with some downtime, probably had to deal with some failures, but what are you going to do? You have to have the resolution. Well, you don't have to make that trade-off anymore. They've got magnetic encoders out there right now that can do 2048 PPR. If you're getting an absolute encoder, they've got 16-bit magnetic encoders out there, so you can get really good performance and get it in something that can be covered in gunk like this and chugging along just happily. On the other hand, the IP-rated optical encoders are significantly better than they used to be, so you will get better performance there, but you're going to be missing a bet if you just jump on to doing that. Another thing to think about, if you've got an application that's got a lot of gearboxes, that can wind up being a real headache over time, depending on the system. That's where you can see a lot of failure. You've got to do maintenance. Very often you've got to lubricate. Yeah, there are lubed for life components, but they sometimes have their problems, so sometimes it's better to not rely on that and to go ahead and do it yourself. But that's time, that's energy, that's running the risk of downtime. Instead, now you can buy direct drive motors that can totally take the place of your gearbox and give you muscle. We're not talking about little itty-bitty, fractional Newton meter type powers. These direct drive motors are really strong enough to do heavy industrial muscle. So as I say, it is a new game, and if you're looking at an upgrade, you need to kind of walk in fresh, talk about your application, make sure whoever you're dealing with understands what it is you're looking for, and see what they have to offer. Don't look for the one-to-one, because that's going to do a disservice. So now that we've kind of talked about the why and how you figure out, let's talk about the how. And my first caution of the how is the benefit that you're going to get out of the upgrade is going to be directly proportional to how effectively you do the upgrade. And it's not, there are some pitfalls and some easy mistakes that folks make. So we're going to talk about some of those issues. First thing you really want to do is define the scope of the whole project. You know where you are right now. What is it that you're going to be upgrading? Are you just going to be doing drives? Do you want to do drives and motors? Is it just feedback? Is it all of the above? That's going to have a real effect on what it is you should go ahead and choose, and whether you're going to be dealing with one vendor, multiple vendors, that sort of thing. But kind of the follow-on to this is you have to look at this within the context of a long-term strategy, because right now everybody's concerned. I mean, I suppose they're always concerned, but people are concerned about funding and so on. Long-term strategy, you may choose to do some sort of a staged upgrade, and that's great, but you've got to make sure that you do it kind of keeping it all in mind. If you're going to upgrade your drives, you need to make sure that if the next plan is to upgrade your feedback or vice versa, that you're getting something that's compatible and that you're kind of taking a big picture view of it. And of course, the other thing you have to think about is budget. Something that tends to get overlooked quite frequently, because usually when you're trying to get approval for something like this, you're worrying about making the case, you're worrying about making the capital outlay. But the cost of ownership, especially when you're talking about 5, 10, 20 year operating lifetime, the cost of operation is going to dwarf your cost of acquisition. So it's really key to make the right choices on your acquisition so that you get the benefits out of it and you're able to control your operating costs and get the return on investment, so that don't fall into the trap of penny wise and pound foolish, because that is not ultimately in these kind of time frames really going to benefit you. You've got to look at the big picture. Even if another department is the one that has responsibility, even if you're not part of maintenance, it still behooves you for the company to kind of look at the big picture. So what next is you need to think about your timeline. And we're back to the kicking and screaming, folks. So you found out that a key drive or encoder got sunsetted. One response is certainly to buy up all the spares. And there are plenty of companies out there that sell spares. They'll even keep them on ice for you, so that they're there when you want them. And yeah, that'll be somewhat of a help, but sooner or later your spares are going to run out. And when you have to buy more, they're going to start costing more. But ultimately, you're going to have to upgrade. So the question is, do you stick with what you've got and ignore all of the kind of the cost-benefit stuff we've been talking about earlier and upgrade later, or do you want to upgrade now and get those benefits? And I would certainly argue doing it sooner. Now, that kind of dovetails into a couple of other opportunities or other techniques, strategies, that's the word we want, strategies for the timeline is that you can do the all-at-once version, or you can do the staged rollout. Now, if you do it all at once, I mean, it's tempting in that, okay, you shut down the line and boom, 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 you put it all in. That's the theory anyway, but it's funny, you know, number one, you're going to get a full stoppage in output, but this technique also only works if there aren't any surprises, and especially when you're doing a big, ambitious, we're doing, you know, 100-axis machine, there are going to be surprises. So you may find that you get a much better commissioning if you do it in stage. So you've got a subset, you can upgrade those axes. That's going to let you work out the bugs. When you pull out the component that's obsolete, then you've got more spares to use for your other axes while you're waiting to get to them. It's just going to be easier, especially since in some cases, and this was the observation of an engineer I was talking to the other day, you don't necessarily know when you're trying out some of these new sets of components exactly how it's all going to work until you get it on the machine, you get everything tuned and so on. So if you're trying to do that to your entire machine or your entire line simultaneously, you're being ambitious. And there are other kind of more nuanced ramifications. Companies that are producing FDA-regulated products, for example, there's an FDA standard that says if you are making a change to your manufacturing facility, you need to have the ability to reverse those changes within 24 hours if it doesn't work. If you're trying to upgrade an entire machine or an entire line, that's going to be a lot harder to do if you do it in one subset and you can find the problems and troubleshoot so that everything goes out smoothly. You're going to be life's going to be much more simple. So let's see. So we know the what, we know the when. What about the how? Got to think about exactly how this is going to go on now. Sometimes some companies deal with integrators, some companies, again, with an eye on economy, deal with in-house staff. You've got to make sure that whoever is doing this is going to have the chops, especially if they're in your organization. And one of the questions you probably ought to ask yourself is that our core value prop, and is that where we want to spend our time? Because some of these upgrades can be complicated. It's not your core value prop. It might be easier to get somebody else doing the issues and to have the support. It's important to also know this because when you go to buy your components, it may make more sense to get a more capable, comprehensive component, because if you aren't going to have sophisticated support, then you want to have something that's bulletproof, something that's going to run for a long time without any problems. So that might be one of those cases where, yes, you're going to save some money not working with an integrator, but you might want to invest a little bit more in the components to get higher degrees of functionality. For example, some of the condition monitoring capabilities and so on, to make sure that you're kind of balancing. Because you don't just have to think about putting it in. You've got to think about who's out there at your company that's going to keep it running. Do you have the skill set in-house? If your folks are basically hardcore on hydraulics, are they going to be able to deal with servos? And if so, you know, how effective are they going to be? Is your vendor going to be able to give them training? Do you have the option of service level agreements? And always, what happens as far as budgeting and so on? Do you need to hire new staff, et cetera? So something else to keep in mind. And then let's talk about some of the more concrete issues of compatibility. And one of those is the electrical considerations. Feedback, for example. Your encoders and resolvers, for the most part, they're going to generate a pulse stream for you, but it's going to have to go to your controller, and that's where it's going to get processed into your position or your velocity data. So one of the key things that you've got to know is, will your encoder, if you're buying a new one, your feedback device, be able to communicate with the rest of the machine? What kind of a signal does it need? Is it compatible? If digital encoders, absolute encoders can do wonderful things, but if you've got a 20 or 30-year-old drive that's an analog drive, you're going to be out of luck when it comes to integrating that, which could argue for getting an analog encoder, and that would certainly be one way to solve it. But back to the discussion earlier, if you're staging it and next year you're upgrading your drives, you're going to have another headache on your hands. So if your drives are going digital. So then the question is, how do you go from dealing with this analog drive to getting a digital encoder to being able to go to a digital drive? And one way you can do it is do a frequency to voltage converter in the encoder, and that way it can go ahead and deliver the analog drive the analog signal that it needs. But when you're ready to upgrade your drives to digital, that digital encoder is going to be compatible with those two. So you've gotten a short-term improvement, but you've also kind of future-proofed the system. So that's the kind of stuff that you just really need to keep in mind. Think about your output drivers that your components need. Think about your operating parameters, and so on. And of course, while we're talking about interoperability, it's really important to not just think about the other electrical elements within a single machine, but you've got a factory floor. A lot of these lines are highly integrated. You've got robot arms that are loading pallets or loading flat carton flats into the converters or whatever. You've got in-feed, out-feed, and there are standards obviously in place to help with the interoperability, but fundamentally the new components need to be able to operate with those systems. You need to, going back to the previous example, everything's got to have compatible signals, compatible formats. Another thing to keep in mind when you've got a really big floor is the whole inventory issue and spares. And this is kind of one of those sort of squishy things. I talk to the motor manufacturers, and they're always saying, "Humps, people buy motors that are like way bigger than they need to be because they're afraid because they weren't a little bit warm, and they ought to be able to right-size them." And right-sizing a motor will save you money in the most absolute sense. But at the same time, the problem that you can run into with doing that is you're going to have a ton of spares, and that ties up a lot of money in inventory. So if you're trying to look at an upgrade, you want to try to get some commonality among your axes, not just in whatever machine you're upgrading, but if you can make sure that that can carry over and work with the spares used on other modules, or keep it in mind in the future when you're upgrading those other modules. So things to keep in mind. Now, from a mechanical standpoint, starts out with the silly, but you got to make sure it'll fit. One of the driving, everybody knows that space is money when it comes to factories. So footprint is huge. OEMs are always trying to minimize that and pack as much performance as they can in the smallest possible package, which is great until you try to come in and retrofit the electronics, and all of a sudden you're trying to fit things in to a cabinet where there's not room, or hanging on the machine where there's not room. So it's important to keep in mind, and in general, newer components tend to be smaller than older components, but not necessarily. So always keep in mind that it's not enough that it performs. You got to be able to put it on the machine. Mechanical parameters that you really do want to keep in mind, in addition to just is a physical space, shaft diameters. If you're putting an encoder on a motor shaft, you need to make sure that it's going to match, whether you're trying to do a shafted version connected with a coupler, whether you're trying to do a shaftless version, or a hollow shaft that's going to fit over the motor shaft. Shaft runout is another thing that's particularly important when you're looking at machines that are, again, running 10, 20, 30 years. I mean, the rules really do change for these machines that have been out there so long. So you've got to keep that in mind. You've got to make sure you're looking for compatible bearings. Another thing to keep in mind with the mechanical parameters, though, is you have new options in this day and age. And for a long time, it was basically a shafted, like encoders. A shafted encoder coupled to the motor, and you're off to the races. But these days, you've got hollow shaft encoders, you've got touchless encoders, bearingless encoders, where you don't even have to have the sensor next to the magnet. So there are a lot of degrees of freedom there. There are new degrees of freedom and form factors in your motors, in your drives. You've got the option of distributed control because of the smart drives, and that changes your form factors and so on. So again, it kind of comes back to that same thing I've been beating, but you need to really be aware of what's out there, because there are some much, much stronger solutions than there ever were back when your machine was first built. Anyway, so here we are. I think actually I raced through this. But yeah, here we are. These are a few people who provided input for this webinar and some of the good stories that I had. So my appreciation to these guys. And at this point, I'm going to turn it all back over to Kathleen. Oh, actually, no, I'm not either. I'm going to do the conclusions first. I lied. So conclusion is, if you do it right, you can get good ROI very quickly on an upgrade. Again, 20% increase in throughput. That's pretty impressive. But you need to do it right. You need to know what's out there. You need to be clear on your project planning. Decide how you're going to roll it out. Make sure that when you've got it in place, it's compatible with the skill sets of your staff. Make sure that it's compatible with your existing equipment. And by the way, the system in that picture is a printing machine that's running on direct drive servo motors. So, yet another example of not your daddy's servo motor anymore. So anyway, all right, so now I will turn it back over to Kathleen. Thank you very much for your time and attention. I appreciate you listening.
Thank you so much, Kristen, for that informative webinar, and thank you to all the participants today. Kristen has written numerous articles for our website, motioncontrolonline.org, so be sure to check them out, as well as our list of upcoming webinars. As a reminder, the webinar has been recorded, and an email with a link to the recording will be sent to you shortly. Kristen's contact information is up online, so if you have questions on the material, please feel free to contact her directly. Thanks again to Kristen, to everyone who attended, and have a great day.